Hello and welcome to the Maths Matrix. My name's Rebecca and in today's video we're going to be doing expressing a number as a product of its prime factors. All you'll need for today's lesson is paper and a pen. I'm going to pop a list of questions on screen. If you know that you would know how to do those and you understand what the question is asking of you, then you don't need to watch this video, you can just skip on to the next one. If you don't know what the question's exactly asking you to do, or you don't know how to do it, then stick with the video. That's what we'll cover today, and then I'll show you the questions again at the end, and hopefully by then you'll be able to do them. So here are the questions now. Okay, if you're still here, then I'm assuming that you either didn't know what those questions meant or weren't sure how to do them. So let's get started. I've been really looking forward to today's video actually, because this is where I consider that proper GCSE content really begins. This topic's quite often on both foundation tier and higher tier papers, usually on a non-calculator paper, but not always. And when it's usually on for 3 marks, and if you know how to do it, they're really nice, easy marks. I'm always very pleased when I see that this topic's been on an exam, because I always think, hopefully my students got that one right. So let's get on with it. If you put a title of prime factors, and then in case you don't know what prime numbers are, we'd better start by defining those. So underneath that, underneath your title, just put a prime number is a number that can only be divided by itself and 1. The first few prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23. All right, so you'll notice in that list it goes 2, 3, 5, 7. People always want to put 9 in the list. 9 is not a prime number because 9 divides by 3. Likewise, 15 isn't in the list because 15 divides by 3 and divides by 5. So a number is prime if it doesn't divide by anything except itself and 1, or rather doesn't divide wholly by anything other than itself and 1. So anything else would produce a decimal answer. Right, so that's what prime numbers are. If you then put every number in the world can be uniquely expressed as a product of prime factors. Okay, so what I mean by that is that if you take a number and break it down into a product of its prime factors, the exact list of numbers that you have at the end will be unique to that one number that you started with. So no other number in the world will have that exact combination of prime factors. So every number that exists can be broken down into a product of prime factors, and no 2 numbers have the exact same combination. Right, continuing with your notes, put if on an exam you are asked to express a number as a product of its prime factors, draw a factor tree and use this to help. and then put e.g. express 120 as a product of its prime factors. And actually do write that whole phrase down, because if you just put 120, that's fine. But if you don't put the full phrasing down and then you see that phrasing in an exam, you might not know what the question's actually asking of you. So in this worked example, make sure that you have the whole question written so that if you see that come up on a mock or on an exam, you'll understand that this is what it's referring to, what we're about to do now. So to actually answer that question, what we would do is we would write down the number 120 and we would draw two branches coming off it. And then we would think of any two numbers that multiply to give 120. So the most obvious one that a lot of you might be thinking of is 2 times 60. And that's absolutely fine. You can put 2 in 60 if you want to. But if the number ends in a 0, to make the factor tree a little bit smaller and to make the process a little bit quicker, what I like to do is use 10, because if anything ends in a 0, you know that it definitely divides by 10. So what I'm going to pick is 12 and 10. 12 times 10 makes 120. But any two numbers that multiply to give 120 will do at this stage, because what we're now going to do is break those down further. So I'm going to break 12 down into 2 times 6. And then what we do is when we encounter a prime number, we put a circle around it. So I'm going to circle that 2. But I'm not going to circle 6 because 6 is not a prime number. So I'm going to break the 6 down into 2 times 3. And both of those are prime. So I'm going to put circles around each of them. Then coming over to the 10, 10 breaks down into 2 times 5. And each of those are prime. So I'm going to put circles around those as well. And then everything then has a circle round it, so nothing else needs breaking down. I've reached the end of each kind of branch, if you like. So what that means is that 120 equals 2 times 2 times 2 times 3 times 5. You don't have to write them in numerical order, but it's just conventional to do so. So that's usually how you'll see it in answers in numerical order. And we do need to put the times signs in. People sometimes remember this part, but they can't remember whether they need to put times signs in. You do need to put times signs in because the word product actually means multiply. So way back in infant school, you'll learn that the sum of means add together, or the total means add together. You learn that the difference means do a takeaway. And you do learn that the product means multiply, but you actually use that a lot less between junior school and senior school. So a lot of people forget it along the way, but product means times. And so you do have to put the times signs in. Now, if the question asks you to give your answer in index form, what you then do is you put 2, and then because there's 3 of them, you put a little 3 in the air like that. So 2 to the power 3 times 3 times 5. So that there is index form. So sometimes the question will say express 120 as a product of its prime factors, giving your answer in index form, which means that you must put that part. So what I always say to people is do your factor tree, do that, and then to be on the safe side, give your answer in index form anyway, whether or not they asked for it, so that you'll definitely be sure of the mark. All right. So let's do another one. So if we do, what did I put? 480. So if you put e.g. express 480 as a product of its prime factors. And then because that ends in a 0 again, I can make life a bit quicker by choosing 48 and 10 in my tree. But if you didn't realise that in the exam, if instead you went for 2 and 240, or you went for 80 times 6, you'd all get the same answer in the end. It's just a bit quicker if it does have a 0 on the end to use 10 as one of them. So I can break 48 down, and I'm going to go for 6 and 8. But if you went for 12 and 4 or 3 and 16, that would be fine as well. Then neither of those are prime, so I'm going to break that down into 2 times 3, both of which are prime, so I can circle. And then 8 breaks down into 2, which is prime, times 4, which isn't. So I can break the 4 down into 2 times 2 and circle each of those. And then coming back to the 10, 10 breaks down into 2 times 5, both of which are prime. So I'll circle each of those. And that tells me that 480 equals 2 times 2 times 2 times 2 times 2 times 3 times 5, which is 2 to the power 1, 2, 3, 4, 5. So 2 to the power 5 times by 3 times by 5. And that's your final answer in index form. Okay. Let's do another one. So this time, let's have 621. So again, the question would be express 621 as a product of its prime factors. Now this one is a bit trickier because it's not even, so it doesn't divide by 2. It doesn't end in 5, so it doesn't divide by 5. It doesn't end in 0, so it doesn't divide by 10. So what we have to do with this one is check whether it divides by 3 or by 9. And if it didn't divide by those, then we might try 7. Now, there's a test you can do. Some of you might already know it. You can do what's called the digits test to check if a number divides by 3 or by 9. And what we do is we add up the digits of a given number. So if we have 621, if I add up 6 and 2 and 1, I get 9. And 9 does divide by 3. So I know at a glance that 621 definitely divides by 3. So if that rule is one that you weren't aware of, just put in your notes. To check if a number divides by 3, add up its digits. If the answer divides by 3, then the original number also divides by 3. Okay. And that same digits test can also be used to check if a number divides by 9. So again, taking the number 621, 6 plus 2 plus 1 equals 9, and 9 divides by 9. So not only does 621 divide by 3, it also divides by 9. So the digits test works for checking for divisibility by 3 and for checking for divisibility by 9. So again, if that was something you didn't know, put to check if a number divides by 9. Add up its digits. If the answer divides by 9, then the original number also divides by 9. And that gives you a really neat way for checking if larger numbers divide by 3 or by 9, which can be really useful not only for drawing factor trees, but also for cancelling down fractions. So people are usually quite happy to cancel down a fraction if both the numerator and the denominator are even, because they know they can just divide top and bottom by 2. But if they've got odd numbers, they don't like that as much because they're not always sure then what they can divide by. But if you know about the digits test trick, then you can tell at a glance if any given number divides by 3 or divides by 9. So if, for example, I take the number 105, 1 plus 0 plus 5 gives 6, and 6 divides by 3. So I know at a glance that 105 definitely divides by 3. However, 6 does not divide by 9. So I know at a glance that 105 does not divide by 9. So it's a really useful little trick for testing what things divide by. And between the digits test and what you know about 2, 5 and 10, you can check then for whether a given number divides by quite a few things. So if a number is even, it definitely divides by 2. So if you don't know what else to divide by, you can divide by 2. You can apply the digits test to see if it divides by 3. And a number will only divide by 4 if it's even, in which case you'll already have spotted that it's even and will have divided by 2. So you don't tend to need to check if numbers divide by 4. Not every even number divides by 4, but a number will only divide by 4 if it's even. A number divides by 5 if it ends in 5 or 0. So you can tell at a glance if a number divides by 5. Only even numbers divide by 6. So again, if it was even, you probably already divided it by 2. So you don't tend to need to check for 6s. Not every even number divides by 6, but only even numbers divide by 6. 7, you just don't bother about. There is a test, I think, for 7, but it's not one that you learn in school. So don't worry about 7. You just have to check if a number divided by 7 by literally writing it under a bus stop sign and seeing if 7 went into it. 8, only even numbers divide by 8. If it was even, you'll probably have divided by 2. And 9, there's a digits test. Numbers divide by 10 if they end in 0. And that's probably about all you'll need to check really for prime factors. If it's none of those, then you'll have to get doing 11 or 13 bus stop method at the side, or else if you're on a calculator paper, just use your calculator to check, does it divide by 11, does it divide by 13, or whatever other primes you might be checking for. But up here, I've ascertained that 621 definitely divides by 9, so I can use 9. Now I don't know off the top of my head what 621 divided by 9 is, so this is where being able to do bus stop division comes in, because what I'll now do is I'll say 9 into 6 doesn't go with 6 leftovers. 9's into 62, 9, 18, 27, 36, 45, 54. The next one will be 63, which is too much, so it goes in 6 times with 8 leftovers, and 9's into 81, go 69. So that tells me that 9 times 69 is 621. So although they're probably not going to check your division directly in a do this divide question on a non-calculator paper, this is the kind of question where they might check, can you do bus stop division? So make sure you can. Neither 9 nor 69 are prime, but 9 breaks down into 3 times 3, both of which are prime, so I'll circle them. 69, applying the digits test, 6 plus 9 is 15, and 15 divides by 3. So 69 definitely divides by 3. if you didn't know what that was at a glance, you'd set it up bus stop again. 3 into 6 goes twice, and 3 into 9 goes 3 times. So I'm going to have 3 times 23, and 23 is prime, so I circle that as well. So that tells me that 621 equals 3 times 3 times 3 times 23, which equals 3 to the power 3 times 23. Okay, so that's the answer for that one. Okay, and that's all there is to those. So if you're asked to express a number as a product of its prime factors, draw yourself a factor tree, circle any primes, and when the end of every road is circled, you can bob your answer down. I'm not going to show you any more because that is all there is to them. They don't get any worse than that, really. You might get bigger numbers where you have to do more bus stop division down the side, but they never differ in how they're done. That is always the case. Also, when we come on to do highest common factor and lowest common multiple, you'll be doing a lot of factor trees as part of that work as well. So it's not something that you need to practice too much as a topic in its own right, because factor trees are also one of the ways in which you begin highest common factor and lowest common multiple questions. So you'll get lots of additional practice at doing them there. So now I've shown you those 3, hopefully you've got the hang of them. And what I'm going to do now is the questions that I put on screen at the beginning, I'm going to show you those again. You can hit pause and have a go at them. And then when you've done them, hit play, and I'll put a second sheet up with the answers on so that you'll be able to check whether or not you got them right. All right, so thank you for watching, and I will see you next time. Bye.